welcome to my channel. My name is Fikrat. This video continues video tutorial series dedicated to learning Microsoft Fabric. In the last two videos, we started conversation around real-time analytics in Microsoft Fabric. So we learned ingesting data using Fabric's no-code pipelines like event streams. We also took a quick look at KQL database, which is more on the side of code-first experience. And today we're going to focus on transformations on KQL. KQL language is extremely powerful and flexible. I enjoyed learning that. Today we're going to look at basic transformation techniques in KQL, as well as we'll build end-to-end pipeline, which will take ingested data and apply certain transformations, some cleansing operations, dimensional modeling, and so on and so forth. Stick around to learn more about that. Here is a quick preview of what I'm going to cover today. We'll start with the exploring of KQL Querysets. KQL Querysets allow you to store your queries and the transformations. Then we'll take a look at basic KQL transformations. We'll start with basic transformations like project, extend, parse, web. So these are considered operators. Then we'll take a look at table management commands like create, drop, alter. Then we'll explore let operators and the functions which allow you to build multi-step transformations. Next we are going to explore table writing commands like append, settle append. Then we'll move into a discussion around automation of transformations. So in any ETL, you would expect your transformation to run in automatic fashion. There are multiple mechanisms in KQL allowing automatic data movement and the transformations. So you can use either data factory, then you can also use data policies like cache retention or table updates policies. Then you can also use Materialized view. So I'm going to demonstrate each of these in a concrete examples. In the next section of demo, we're going to build end-to-end pipeline, which will take data ingested from event hubs and apply different transformations. So I will start by data enrichment and the cleansing techniques where we'll parse the nested data, apply filtering, apply data type conversions and the deduplication. We will also apply dimensional modeling techniques. So we will learn how to split data into facts and the dimensions. I will also learn how to use materialized views. In the final section of this tutorial, we're going to explore visualizations that are available in KQL. So we'll explore render operators that allow to build charts within KQL data exploration screens. Then we will take a look at Power BI visualizations which allow you to create permanent dashboards. A quick reminder before we proceed, if you are new to the channel, please take a moment and subscribe so that you could always receive my latest tutorials. Let's get started. All right, I am in Microsoft Fabric's homepage. I have selected real-time analytics. Let me start by creating KQL Querysets. KQL Querysets are query containers which can contain one or more queries, KQL queries. They will be stored on workspace level, and you can, once you create it, you can always come back and run them. So there are different ways of creating KQL Querysets. One easy way is using new button on the home page. You can also create KQL query sets from inside KQL database. Let me use this option first. So I'll need to name my query. So let's say test4. And then I have to select my database. So once created, it will present few sample queries where all you need is just to replace your table name. So within query set, you can create multiple tabs. So for example, I can create this tab and name this tab, let's say, queries. So this could be exploratory queries, so on and so forth. For the purpose of this demo, I'm gonna use vehicle traffic data that I created using data from Azure Event Hubs. So within Azure Event Hubs, you can generate sample data sets. There is a data set which represents vehicle toll booth information. So that's what I generated from Azure Event Hubs. And once you have data from in Event Hubs, there are multiple ways of connecting from KQL and bringing that data. If I go to KQL database, so you can either use from home page get data option, or you can use event stream options. If you are interested more about learning how to ingest data from Azure Event Hubs, I would suggest you to take a look at Realtime introduction video that I have recently posted. For now though, I will navigate to KQL query sets that I have created earlier. So the query sets that I have created will allow us to go from simple to more complex. And I'm going to share this in the video description. So it starts with the very basic query, which takes a table name, and applies row count limit. So this operator is called take. So typical KQL queries start with the table name, followed by different operators. And these operators are joined by this symbol. You can run query either by putting your cursor on somewhere within the query, or you can select certain part of the query. So let me run the first query to take a look at the data. So we have some simple columns which represents entry time for toll booth, and then car information, which is complex type. So we have structure with car make, model, and so on and so forth. And then we have some state information, we have some numeric columns, some date timestamp columns representing ingestion time, and we have license plate information, which is kind of primary key for this data. Now let's take a look at another query which selects certain columns from this table. So the project operator allows you to limit output to certain columns. You can also apply certain expressions and conversions. So in this case, you can see that I'm using toInt function to convert data type to integer. So let me run this. Another operator that allows you to do column transformations is parse. There are different variations of parse operators. So this one is called parse keyword. It allows you to specify keyword dictionary and data types and extract certain parts. So in this case, a car model column is a complex type with different subfields, And in order to extract different parts, I can specify parse key operator and then provide a list of fields alongside with the data types. Another operator type that allows you to do column level transformations is extend, which I brought here. And you can see it works very much like project, where I specify expression and then assign it to certain column name. Now let's take a look at some table level transformations. So one of the most common transformations is a filter transformation. You can use where clause to apply filters. So in this case, I am using where to filter out any rows where license plate is null, and I am using is not null built-in function. Let me run this. Okay, so as you can see, there's still empty rows, and I'm gonna add another condition here. So I'll say and say is not empty license plate. So what's nice with KQL is that it has great IntelliSense. As you type, it will anticipate different operator and functions, and it's context based. So that makes learning KQL very easy. Now my empty rows are gone. Okay, another table level operator is order. So it orders your output data by the column you specify. You can specify one or more columns. Now let's talk about some aggregate operators. So aggregate operators can be created using summarize followed by aggregate function. So in this case, I'm calculating sum of total amount, and then you can also specify group by condition. So what this aggregate query does, it will calculate total amount grouped by total ID. Now let's talk about join operators. You can use join operator followed by table you are joining to, and then you have to specify on clause followed by joining conditions. If you have same column name from both sides, you can simply specify that column name here. If you have different column names from left and the right table side, then you can use conditions like this, where you specify your joining column from left side and the right side. All right, now let's move on to table management commands. KQL commands start with dot symbol. There are common commands like create, drop, which you can apply to creation different objects within KQL. So tables are one of the most common objects. There are also functions that we will be talking about a little later. So this command creates a table. So you have to specify table name and then column description. So each column has column name and the column type. So if I run this, it gives me description of the tables that it created. Drop command allows you to drop the table. There are some commands that allow you to create table and populate it at the same time. So there are a number of set commands that have different variations. So this command, so set or append command, allows you to create table and then it specifies a query that this table will be filled with. So if table is there, then this data will be added to that table. If not, then this table will be created from scratch. So let me run this. The append command works similar way, except the table should be pre-existing there. Okay, now that we have learned basic transformations, let's take a look at some of the query constructs that allows you to write complex queries. The let operator allows you to create multi-step queries. To do that, you have to create definitions of your query. So it has to start with let keyword, followed by a query's name, and then you can also specify certain parameters if needed. And then you have to specify query within curly brackets, like that. Once you have defined your let query, then you can use that query just like any other tables, like that. So let me run this. So folks who are familiar with SQL will remember common table expressions where you can create multiple steps, and name each step. So this works in similar fashion. Another query construct that allows you to create multi-step complex queries in KQL is a function. In difference from let operators, functions create permanent object within your database, and you can always come back and refer to these functions. To create functions, you can use create command. So I will type create function. I need to name the function. So let's say fn test. You can provide parameters for function, and the rest is very much like let operators. So you have to provide curly operators, and you have to bring your query within that operator. So I'll just copy paste my query. Because functions allow you to specify parameters, that allows you to create dynamic, flexible query constructs, which could be very helpful in creating complex queries. All right, now that we learned basic KQL transformations, you might be wondering, how do we automate data movement and transformation within KQL database? There are a few options when it comes to orchestrations. So Data Factory is one of them. So Data Factory is data integration tool within Microsoft. You can build integration pipelines that would include data movement from different sources as well as transformations. So for folks who have had a chance to watch my previous videos on Data Factory, they know that you can do pretty much everything. You can call Spark notebooks from there. You can call stored procedure, SQL stored procedure from there. You can also run KQL commands from Data Factory that I'm going to demonstrate shortly. You can also create materialized views within KQL database. Materialized views behave same way as a materialized view from other database platform. So basically, they allow you to persist your transformations inside the database. So that way, whenever any changes happen in your tables, source tables, these transformations instantly reflect your change. Another automation option is a Spark notebooks. So basically, you can create notebooks which can access custom database and queries. We in past few videos we talked about Spark notebooks, which allow you to use different Spark languages to apply transformation. So that's more on data engineering line. However, great news is that you can also refer to custom tables and the queries directly from Spark notebooks. Then there are some data policies that allows you to automate some data management jobs. So cache policy allows you to identify certain period and dedicate it for so-called hot cache. Basically, that allows KQL treat certain periods in your table history as more important, a priority period, and then it will store that in SSD cache. So that means that queries from these tables will be faster than other tables. So we'll talk about cache policy as well. And then data retention policy allows you to specify certain period after which data will be removed. Finally, table update policy. So this is a nice feature which I'll describe in a moment. So what is table update policy? The table update policy allows you to create automatic background processes that take care of data movement and the transformations. So this diagram that I borrowed from Microsoft website illustrates this update policy very well. So in this example, let's say we have table A, and we know that data from to this table will arrive from a source table. So we can create update policy on table A with the source pointing to this table, source table. So that way, whenever table is updated in source table, your data will be updated automatically on table A. You can create more than one policies from the same source table. So that's what we have. So basically, you can create one policy on table A, another policy on table B. They may have completely different structure. So some of the transformations results will go automatically to table A. Some of them will go to table B. And you can continue this chain. So you can build another table for this table, which will serve as a source. So here's a sample syntax for table update policy. You have to create your table first, of course. And once you create it, then you can use alter table command. You specify your table name, and then these are properties. So basically, you can say is enabled. So is this policy enabled or not? You can turn it on when you create, but if needed, you can pause by turning it off. So basically, setting it to false. Source is a table name which serves as a source. Your target table, and then you can also specify query. This is where you can provide any kind of KQL transformations, and that transformation will be executed anytime your source table updated. Is transactional property is another important attribute. It decides what happens if, for whatever reasons, the update policy you created for, let's say, this table A doesn't work. So let's say you have some errors there. So for some reason, this transformation cannot be performed. For example, you have schema from this transformation does not match your target schema, right? So in this case, if is transactional set to true, then data will stop arriving to your source table. However, if you set it to false, then you can freely update your source table, no matter if your update policy is working or not. Propagate ingestion properties allows you to inherit certain properties from your source table. There are some extent-related properties for any tables. All right, now let me demonstrate how this automation options work on practice. So I am in Microsoft Fabric's homepage, and I have selected Data Factory workload. And from here, I'm going to create data pipeline. So I can assign name, but I'll just leave it as is. So from here, I can add activities using add pipeline activity or top menu. If you are interested to learn more about data factory data integration pipelines, please take a look at a few videos I have posted in my channel. For now, I'll just proceed to create KQL activity. So I'll click this button and I can type it here. So that will be probably easiest way, and select this activity. And once KQL activity added, I can navigate to settings and select my KQL database and put my KQL command, which writes in some destination table. So in this case, it's very simple. Write queries that we have explored earlier, and save it and run it. So let me just quickly run this. And my pipeline runs successfully. All right, now let's take a look at materialized views. So I'm going to switch to my KQL database, and this is a query set I have been working on. So I am creating materialized view here. So as you can see, syntax is pretty much like functions. So basically your transformations will be included within curly brackets. So this is my transformations. And then you have to provide materialized views name, and the table is based on. And then there's some optional properties that you can provide. So for example, if you say backfill equals to true, that means that materialized view will be created and the data will be filled inside it from existing table. If you don't specify that, so by default your materialized view will be created empty. So in this case, my materialized view has aggregate transformation, which basically calculates total toll amount for vehicle traffic data. And so I am going to query that. So once it's created, you can basically treat it just like an ordinary table. All right, now let me move to KQL database main interface. So this was a query set interface. I'm gonna switch to my KQL database. Now let me describe Spark Notebook experience that can refer to custode tables. So it's very easy to create Spark Notebook. So all you need to do is to navigate to home, and from here open new related item and select notebook. So this creates Spark Notebook. What's nice that as Fabric will automatically populate the first command cell that's necessary to connect your to KQL database. So you can see that it already auto-populated connection string, and it provided database name here. It even provided sample custode query. Of course, you can change this custode query as needed, and once ready, all you need is just run that cell. Okay, and that produces the data. So as you can see, referring to custode data is just like creating any other Python data frame. So here's a sample where you use Spark read APIs, and of course you have to provide certain custode specific format and options, but from there it's straightforward. So once you have your data in data frame, of course you can do right into your Delta Lake table. You can apply any Python or Spark transformation on top of that. So great thing is that Spark Notebooks has a lot of different orchestration options. So you can either call Spark Notebooks from Data Factory, or you can schedule it directly to run from within Microsoft Fabric. I have a dedicated video related to scheduling notebook. So if you're interested to learn more, please take a look. All right, let me go back to my KQL database, and now let's explore policies. So I'll start by cache and data retention policies, and you can access them from Manage menu and by navigating to Data Policies command. So from this window, you can specify retention and caching periods in days. You can also turn limited versus unlimited options here. So if you turn unlimited, of course, this retention period will be irrelevant. So I'm going to cancel this. All right, final topic in my automation is update policy. So you can easily create update policy from Home tab. So you can navigate to New and hit Table Update Policy here. So that will present you easily customizable template where you can specify your table name, source, your query, and all other properties. So I already created table update policies that I will be showing as part of end-to-end transformation pipeline within KQL database. Let me just navigate to my KQL query set, and here is my table. So as you can see here, I am creating the table, and then I have alter table command to apply policy, and within policy properties I say it's enabled, and I name my source table name, so it's here, and then I specify query, transformation queries that will be applicable to the source table. So in this case, it's a function that I'm gonna describe shortly. All right, my last demo is going to build end-to-end KQL process, background process, which will have multiple transformation steps. I will be reading from vehicle traffic table that I described earlier. Just to remind you, this table is ingested from Event Hub sample data. And then I will apply certain cleansing transformations to that to create vehicle traffic cleans table that you can see it here. And then once data is cleaned, as a next step, I'm gonna split my data into two tables. So I will separate dimension related data into dim vehicle table, and fact related data will go to fact traffic table. Okay, so let me describe my transformations, and again I am gonna share this KQL notebook so that you could repeat this experiment. All right, now that we know what kind of cleansing transformation is needed, let me show you transformations that I created here. So I encapsulated my transformations within the functions. So I think that's easy way to store your transformation within KQL database. And here, so I name this function as fncleans traffic. And here what I do is just apply filter transformation first. It's here, it just eliminate all the empty rows, which includes null rows as well as blank rows. And then I'm using parse QV operator to extract different parts of car model field. Then I use extend operator to add ingestion time. So I'm using built-in ingestion time function here. Then I use summarize function for deduplication purposes. This works very much like group by. So whoever familiar with SQL, they probably have used group by for the purpose of deduplication. This is a similar technique where I basically provide list of columns by which I want to deduplicate my data, and then here I am specifying a function, maximum function, which will take only last version of my entry time. And finally, my project operator lists all the columns that I need in my target table. So I already created this function. I'm gonna just quickly run just for sanity check. So my data now looks good. So I have got rid of empty rows, and I added ingestion time. All right, my next command creates vehicle traffic claims table. Let me first run this. I already ran this, and I have a table, but I'm gonna quickly drop my table so that I could start from scratch. And I'm gonna create this table. Then I'm gonna run alter table command so that I could apply table update policy to my vehicle traffic cleans table. My next command creates dimension vehicle tables. So as you can see, I have included only vehicle related columns here. So things like license plate, vehicle type, etc., etc. So if I just quickly show you vehicle table structure, we have combination of dimension related columns, things like car model, make, etc., as well as columns that you can consider as a fact column. So here I'm creating a table for dimension table, and then I create function which includes transformations from vehicle traffic cleans table. So this is a straightforward functions. All I am doing is using project operator, and then I also apply join here against target table. So basically this transformation reads from my cleans table, and then for selected columns it will compare results to the data in my destination table. So this is common technique when you want to ensure that data that you are ingesting here is not in your target table, right? So yeah, I'm basically joining this my source data against destination table, and I am using here left anti-join, which you can see it here. So that basically tells me take anything from your source query which is not present in your destination. Okay, so let me run these two commands. So I'll first create, let me first drop my dimension table. If it's there, I'll create my dim vehicle table, and then I'll create this function. Finally, I'm going to apply table update policy to my dim vehicles table. For this table, I'm going to specify vehicle traffic cleans table as a source, and then I'll say use this function that I just described as my query. Okay, so let me run this policy update, and then my fact table is designed similar way. Basically, I collected here columns that are relevant to my fact, and so let me just quickly remove this and recreate my table. And my fact transformation is designed similar way as my dimension. So basically I select from source table and apply project operator to select necessary columns. Let me create this function first. And then finally, I'm gonna apply update policy to my fact traffic table. All right, to recap, I created a two-step transformation pipeline where I first cleanse my data and write into vehicle traffic cleans table. And then I have two other update policies which will take data relevant to dimensions to dimension table, and similarly put fact related table to fact traffic table. So for now my tables are empty. Now I'm gonna turn on my event hub streams, and we'll see what happens. So I'm gonna navigate to my event hub, and we'll navigate to generate data. And from here, I'm gonna select vehicle toll booth. Now I'm gonna generate 100 events. Now I'm gonna go back to my KQL database, give it a little time, and browse my cleans table. So let's first browse my cleans table first. Okay, so I can see the data. So now it's cleansed and nice. So if I take a look at my dim vehicles table, it has dimension related columns. And similarly, my fact table contains fact specific columns. One thing to note here is that for all policies that I have created here, I have specified is transactional property as false, and that's on purpose because when I was working with this script, I found that at some point data stops arriving to my source table. So that was first a little bit confusing. And then I realized that I had some issues with my transformations, and I have subsequently fixed that, but I just left it here. So this is important attributes that you need to keep in mind. Another tip here is that if you run into some issues with update policies, there is a command that you can run. So show ingestion failures command that I have provided here allows you to review all of the issues that you might have with your ingestion. So let me run this just to give you some example data. Here you will find a database table, so timestamp whenever some ingestion fails, and you can go and see all the other troubleshooting information that's very helpful. The last command that you'll find within this script creates materialized view. So we already considered syntax for materialized view. So this materialized view summarizes traffic data. So it totals toll amount based on state, toll ID, entry month. So as you can see, I am applying certain functions here, timestamp functions. So I already created this materialized view, and now I can query this view just like any other table. So let me run this. All right, that concludes transformation part of my demo. Before I wrap up, let me demonstrate a couple of visualization options within KQL, which I find fascinating. So the first one is going to be from KQL database itself. It's best for data exploration purposes. So So my next command queries materialized view and brings only top 5 rows. And then I apply a render operator and I say give me results in bar chart format. And I say, and I specify a column by which I want to group by. So let me run this. So there are lots of different types of charts that are available here. So this operator is very good for your data scientists and the data analysts who wants to explore data in place. Another visualization option from KQL is Power BI dashboard. And here you can either divert outcome of your queries to Power BI directly and consume it in Power BI, or you can pick any table and build Power BI reports based on that. So let me quickly demonstrate the first option. So you basically run your query. So I'll just run this query from my materialized view and we'll call build Power BI report. And now my query result is available for building dashboard. Let me close this and show you the second option. So if I go to KQL database interface from here, so I have fact traffic table, so I can select this and click build Power BI report. And now I will just quickly build bar chart. So let's say I want to see total of my toll amount by state. So let me just select bar chart here, and then on the x-axis I'm gonna use state, and I'll use toll ID in my legends, and I'll bring toll amount as y-axis. Okay, so let me just expand this. So let me go to my event hub and generate more records. So if I select vehicle toolbox and let's say I want to generate 100 more, and I'll do it a couple of times to get some traffic. And if I come back to my report, there is a refresh frequency settings that you can set for Power BI reports, which I think is range from 15 minutes to several hours. Power BI Premium, you can even get more frequency. However, you can always do manual refresh, which I'm going to do from here. So let's say I refresh. Now I see that my numbers have increased. So once I'm satisfied with the report, I can save it to my workplace. Let's say now I can come to my workspace and find my report. All right, so that concludes today's discussion. To summarize, we learned basic KQL transformations. We also learned different ways of automating transformations, including table updates, and the data factory. I understand we barely scratched the surface, so there are a lot more to learn about KQL. I would encourage you to play with KQL. There are lots of tutorials and online materials to learn KQL because it's not a new technology. And I want to thank you for your time today, and I hope to meet you in future videos.